always me, me. Well, guess what? Now it's my turn. You just shut up and pay attention. You are mean to me. You. But I Good afternoon, everybody. Let's get started on today's lesson. We are going to go talk. We're going to talk about the value of E and how that came to being. In the meantime, if you guys could just please have your homework out. I want to make sure that we go over that first. So our homework. I gave you compound interest questions last time, and building upon from that formula, we can get to the value of E and where that came from and all that good stuff. I don't know if I mentioned this to you before, but for the duration of the marking period, there's not going to be an assessment, but however, there will be an assessment next week when we come back to school, because now after we talk about E, we pretty much have talked about everything, logarithmic properties, solving word problems, exponential equations and things like that, and just giving a little, brief sketches and overviews. And then after this, we'll move on to trigonometric functions and how to sketch on those. All right, so question number one. $100 in your bank account at 4% interest compounded semi-annually. So how do you determine whether it's going to be like a compound interest versus like a simple interest? Well, they will usually tell you that it's a compound interest rate for most of these anyhow. So write down the compound interest equation and models the given statement here. Let's have Dev. Could you please start us off with how to do part A for this one?
Yeah, my equation was 100 parenthesis 1 plus 0.04 over 2, and then to the second power.
To the second power. Actually, okay, so for this one, actually 2 second power times t, because it didn't really specify the time. And then you use the time as 5 and just plug it in. So using my calculator, I have my calculator here, so I'm using this, the one that I have. 1 plus 0.04 divided by 2 raised to the power of 10, because t is equal to 5. So once you plug it in, and that's what we're supposed to be getting, And so my final answer here, after you plug in 5, I'm going to get about $121.89 or 90 cents here. 121.90. So either one is fine. Whether I tell you round it up or round it down, at the end of the day, if you get the same thing, what you see up here, you should be fine. If the interest was growing annually as a simple interest rate, how much less money compared to part B? Well, all you got to do is just do this, right? 0.04 raised to the power of 10. So if it was a simple interest rate, that means your end value is simply just 1. And so if you use that, 1 plus 0.04 raised to the power of now, I'll say 5. I'm sorry, that should have been 5, not 10. I get 121.665. So let's round it up to 67. And so the growth factor for annual and semi-annual, although they are quite different, and because of the end value and the more frequent times that you're taking the interest of, the more money that you'll get. And that is the main idea that we established last time. When we're asking for the growth factor, it basically means whatever's inside the parentheses. So for annually, it should be 1.04. And this, if you just compute that, that's 1.02. But since we're doing semi-annually, we're taking this to the power of 10 instead of taking it to the power of 5, which, that causes the increase in the amount of dollars. So how much dollars more? It's about 23 cents more you will get by choosing to do semi-annual compound interest rate. Question number 2, given this current inflation rate at Venezuela, now this was an actual current event back in 2018, 2019. The inflation rate for Venezuela it's just ridiculously high because obviously printed more money than they're actually worth. So if you're trying to go out and buy grocery every common day goods like toilet papers or whole chicken on the groceries, it's gonna cost like millions of their currency unit. Just to buy a loaf of bread, it costs just like there's so many zeros after the amount of money that they actually have. So it was getting to the point where the currencies were just practically no value. But because we're using dollars here, you will not see like trillions of dollars, but rather you will see it's a significant increase in the amount of price for roll of paper, toilet paper, or whole chicken. Can I have, let's see. Okay, Sam, tell me the answer for A and B here.
Okay, so for 2A, I got $1.56.
$1.56. I believe that was the correct one. What about the whole chicken for this one?
I got $10.87.
80 cents. About that much. All right, thank you. So 0.4, 1 plus 1.44 divided by monthly, so that's 12. I know that this is a 2019, but to be more precise, ships at February of 2019. So I knew that the question was designed for 1 full year. So that's 12 times 1 to the calculator. So 1 plus 1.44 divided by 12, just to verifying our answers real quick. So you get 1.558. So about 4 times the price increase, which is ridiculous, an amount of, if you're thinking about it in the real world sense. A whole chicken that costs $2, it's gonna about also multiply about by 4. But nevertheless, let's plug it in. 2.79 times 1 plus 1.44 divided by 12 raised to the power of 12, 10.87. So about 7 cents short, but you get the idea. All right, last question, question 3. After 1 year, how much does the population grow by? Now this one I'm gonna go over with you guys. This is a simple interest problem where the interest rate or the rate of increase is 1.5%, because you can see indicated by 0.015. And after 1 year, what that means is you're simply going to plug it into this equation, which you will get as 121,800, because that's 1.5% increase. Now, based on your answer from part A, if you were to divide that by 12, would that be your monthly growth rate? So what does that mean? 1,800 is how much you have grown over the course of years. So if you divide this by 12, you get 150. Now, does this mean that you're growing by 150 per month? The answer to this question, I hope that you guys wrote down, is a big fat no. Why? Because this is an exponential growth. If it's 150 per month, every month you're growing at a very consistent rate, okay? So 150 here, 150 there, 150 there. This is what we call a linear growth, okay? Over time, if you're growing 150 like every month by 150, well, that is not going to give you this curve that's an exponential curve. So if the first one was 150, the next one should be like around like, you know, something more. Next one should be a little something more, a little something more, a little, you know, it's going to keep on continue to grow in terms of its rate. So therefore, no, if you do this, and this is going to be a linear growth, not exponential. And calculate what the population would be after 50 months. Now, I gave you a hint that this is not a compound interest rate question. I know I gave you months, but all you really have to do is convert that into years, which means I have to just divide that by 12. 50 divided by 12, that's 4.167 months. Oh, I'm sorry, 4.167 years. So I'm going to just plug that into the calculator, 1.015, 4.167, or about that much. Raised to the power of 4.167, and you get 127,681 people as my population. Okay. Does anyone have any questions for me on this one? All right, so that was the homework questions, and let's write down some notes for the value of E here, okay? The value of E can be derived from the compound interest rate. The whole purpose of why I taught you that in the first place is, and this is a segment to the compound interest, because as the end value increases in a very specific manner, we'll be able to see where the value of E is coming from, okay? In your notes, this is what I would like you to, for you to write down. It's a big table, yes, I know. And this is the main question I want you to think about. Suppose you invest in a bank $1, and the annual interest is 100%. Pretty much like doubles every year. For a given year, for just 1 year span of time, the time here is always going to be 1 year. I think we all know the end value for annually, semi-annually, quarterly, monthly, weekly, daily. What I want you to do is I want you to use the compound interest rate formula, which states that, and find the exact amount for each and every single one of these if the given scenario is like this. The principal is $1 and the rate is. Let me give you some time to write this down real quick. Whenever you guys are finding the amount for these, please use the calculator and not the phone calculators, but the actual like the Texas Instrument calculators. If you guys have one of those, take that out, please. And let's just talk about annually first and how to figure out the values there. This will be $1 times 1 plus 1/1, because the end value is 1 and the rate is 100%, to the power of n times t. Now remember that because of this, time is always going to be up to only about a year. So it's 1 times 1, which is 1. So now if you type that into the calculator here, I think you're going to get exactly 2. And that should make sense. Your dollar will become $2 after a year if your rate annual interest rate is about 100%. Now, let's say that you're trying to do this semi-annually. So you're taking the principal times 1 plus 1 over 2, because now the end value is 2, to the power of 2. Now, it's going to be tedious to type this in every single time. So what I'm going to do is actually, use the calculator and just use the store button to my advantage. So the question was 1 times 1 plus, I think, let's say 1 divided by x raised to the power of x. The reason why I'm saying x is because that is the end value, and time is already going to be 1, so I can just do that. Okay, so I have x stored as 0, so I have to store the x as 2 first of all. So I can store x as 2 and then just copy this and paste it, and there we go. I'm going to get 2.25. And I can keep on doing this, store 4 as x, and then just scroll up and copy and paste that, and it gives me my next value. So again, there's a benefit of using the store button. I'm using Inspire right now, so it's working a little bit differently. But for TI-84, you can't really make a function here, I think. So the best way to do it is to store the values of x and just keep on copying and pasting this function right there. All right, so that is for quarterly, and let's do it for monthly. Type this and paste that. All right, 2.613. So let me go back to the slides here and just copy some of these down. So for semi-annually, what we got was 2.25. Again, proving that instance where it's as end value is increasing, your value, the amount of yield is going to always increase. When I plug in 4, I get 2.441. And if I plug in 12, I get 2.613. Let's do this again with the weekly. So I'm going to type in that. So if you guys actually type this into the calculator, you should get the same thing as you're seeing here, 2.6926. And let's do the one that's for daily. Store x as 365. And get that value into decimals, I should be able to get 2.71457. Now, I added these 2 extra ones just to show you guys how accurate the value of E is going to approach to, as long as the end value is constantly approaching infinity or getting bigger. So 365 times 60, because that's the amount of hours. Oh, I'm sorry, 365 times 24, what am I saying? 8,760 hours in a year. And then if I multiply that by 3,600, that should give me total amount of seconds. So that should be 31,536,000. Okay. So let's say that I plug actually that into the calculator. Okay. So I'm going to go back to here. I'm going to store x as 8,760, store as x. And let's see what happens when I do that. So I get about 2.71812. And I'm going to type in 31,536,000 and store that into the x. And this is going to be a crazy number. I can feel it. Oh, there we go. So 2.718282473. And guess what, guys? The value of E, and to figure out what the value of E is, if you press second and press the natural log, ln right here, and just do e to the power of 1, able to get like around the same value as which the actual value of E comes out to be 2.718281828. Now, why is the value decreased? That is something that I cannot tell you for sure, but the accurate measurement of E here should be 2.71828. Okay, so which is pretty much approximately the same as when I plug in x as 31 million. So I'm going to go back to my table chart here. When I plug in f of this, okay, so that's 2.71813, and f of that should be 2.71828, which is actually very close to being the value of E. Now, the value of E is basically when the end value gets so infinitely large that you take pretty much what we call the limit of it. And so when n approaches infinity, the value of amount of that is going to be, or the amount that you're going to get that $1 investment is going to turn into, is to about 2.71828. I know it's kind of early for me to show you this, but you're going to see this in pre-calc, honors algebra 3, calculus anyhow. So I'm going to give you this notation here. This is a very standard definition of what E is, and it's in limit form, which states that as limit approaches n is approaching infinity, the value of this equation might seem a little bit odd, but it's basically this. The principal times 1 plus 1 over n to the power of n over n times t, but it's only for a year. So the principal here was $1, so that's why if you take 1 times that, it's going to give you the same thing as what you see up here. This is what we have been doing. You plugged in quarterly, you plugged in monthly, you plugged in weekly into the value of n, and we saw how it kept on getting bigger, and it approaches the value of E, which is 2.71828. And it's an irrational number, which means it keeps on continuing forever and ever and ever. Okay, so that is what the definition of E is here. Okay. And we're going to be utilizing this to solve for what we call continuous growth. The value of E is not defined by a parameter of time. Every single one of the other ones, I ask you that it's compounded daily, compounded weekly, compounded out, E is what we call a continuous function. So as long as, with a given span of time and with a given rate, it's going to continuously grow until the end of, period 1 to period 2, from whatever that time span may be. It's called the continuous growth. And I'm going to show you the equation here. When we say continuous compounding, that compound interest formula turns into something that says A equal to PE to the power of RT. Now you might wonder, why is R at the exponent when R was in the parentheses from the before? So I want to show you how you can derive and how these two things are related to each other. And all you're going to be doing for today is pretty much use the continuous compounding interest formula to solve questions. Okay, I'm going to go back to the slide, but please try to follow what I'm doing on the following notes here. So I'm going to write down the compound interest rate formula and turn this into a continuous compounding interest formula. To do this, it's not going to be feasible unless we call in a separate variable. We're going to need some help. So R over N, so let's say that R over N is going to be equal to 1 over, I don't know, let's call this M. You can call it blob or whatever you want. Why do I want to do that is because of the definition of limits of E, the definition of as n approaches infinity. We want to have this right here, 1 plus 1 over n, or something that looks like that. So if I replace this with 1 over n, I get closer to utilizing E as part of our solution. A is equal to P 1 plus 1 over n. I simply just plug that in there and raise the power of n times t. Now, the problem here is that n is no longer going to be effective. We change the value of n to m right here. And when you take the limit, I'm going to just write here so that I don't have to keep on switching back and forth. We want these two letters to be the same thing. So somehow I want to transform this n into a terms of m. And by all means, you can use the previous formula, r over n equals 1 over m, to accomplish that. We can cross multiply here and say r times n equals n. And that's basically what I'm going to plug in right there. So I can get it in terms of m. A is equal to P times 1 plus 1 over time to the power of MRT. Now, the reason why I want to write M first is that if you just take a look at this component right here, if we're talking about continuous functions, that means that m is approaching infinity because you're doing this infinite amount of times within a given span of year. That's called continuously taking the interest over the span of time. So that means this entire thing is going to turn out to be E, whereas everything else just stays the same. So it's going to be P comes down here, and the only thing that's left over as the exponent is to the power of RT. And so that is where a continuous growth equation came from. Okay, so A is equal to PERT, I would say. This is the work for it, but if you need to see this slide again, just let me know. Again, roughly continuous compounding describes interest rate being added in the instant it is earned. It's going to be continuously having the compound interest being added and added on top of it to the original for a duration of time. And let's apply this to solve some questions here. And then I'm going to give you an extra ticket and we're going to call it a day for today. All right, so suppose that there's $1,000 and is invested at 3% annual interest. What is the accumulation after 10 years if it is compounded monthly, daily, and continuously? Now notice that continuously is going to have the highest output possible out there. So N value is 12, N value is 365, N value is infinity because that's what continuous means. And what you're going to do is you're going to use your compound interest rate formula, right? Oh, I'm sorry, that should be P. Principal times 1 plus R over N. Principal plus 1 over N, 1 plus R over N to N to the power of NT. But for continuous function, we must use this because that takes care of our growth factor. Let me give you like 2-3 minutes. Type this into the calculator. Remember, we have 3%, the principal, and the time. So all you got to do is just really plug it in and then just get the answers right away. Sophie, do you happen to have the answers to, if possible, all of it?
No, sorry, not yet.
Not yet? Okay. Do you have at least one of them? You can tell me?
I'm still working on it. Sorry.
Okay. It's okay. Make sure when you guys are typing this into the calculator that the only thing I'm worried about is parentheses and having the right values. Like, you know, the calculator has to tell you the right values. We'll be able to check to see whether using the on the X ticket, but watch out for the parentheses. That's the only thing I'm going to really ask you to pay attention to. If that's the case, can I have a volunteer from any one of you guys for the answers that we have for n is equal to 12, 30, 65, and infinity?
I think I have it.
Yes, please share.
For monthly, I got 1,349.35.
Perfect.
And then for daily, I got 1,349.84.
Excellent. And last one?
And the last one, 1,349.86.
Excellent. So as you can see, yes, the value that don't change by much, but again, it really proves to show that the continuous function really prevails in turn, giving you the highest output there possible. Okay. So when it's a continuous function, please utilize the e, the value of e. That really has to deal with continuous functions. That is the main idea for today, and you guys already have homework based on this. Again, same. Did someone have a question?
Yeah, can you show the work for the last one?
Sure, yeah. So the last one is PE to the power of RT. So principal is going to be 1,000. We have E, which is 2.7, blah, blah, blah. And then the rate is 0.03 and time is going to be 10 years. So I can go to my calculator here and type in 1,000. And you have to press second natural log to get that E to the value of 0.03 times 10 years. And that's the value that we should be getting.
Okay, thank you.
No problem. Again, privately message me. If I tell you you're good to go, you are good to go. This is the exit ticket question, but I'm going to modify this a little bit because it's a really no-brainer if I just give it to you like this. You're still telling me which is going to be a better deal. Deal A gives, or the account, gives you that 7% interest compounded quarterly for 2 years. Okay, just please pay attention to the time. Or one that pays, we're going to call this deal B, that pays 6.95% compounded continuously for 1 year. In the chat, privately message me which deal is better. So deal A or B is better by how much money in difference. You have to use the calculator to calculate the value of the amount that you get paid for deal A, the amount that you get paid for deal B, and subtract it and tell me the difference between those two. No cheating, please. Just, I know all of you guys can type the correct numbers into the calculator and let the calculator do the work for you and tell me the right answer for it. So take maybe about 2-3 minutes of your time. And I'm going to put in the grades.
Mr. Kim, what's the p-value?
The p-value is, sorry about that, I forgot. It really doesn't matter which it's going to be, but let's call it $100 just for the sake. Joshua Spence, the time here is for 2 years for deal A and time is for 1 year for deal B. Okay, Abby, Linda, Dev, Kira, you're all good to go. Have a great day and have a great weekend too. Zach, please try again. Maybe your I'm only assuming that the calculator is making an issue there. Danny, private message for me, please. And could you just, Danny, can you just try this one more time? If you, it's close, but it's just wanted you to double check the answers real quick. Tony, also maybe there was like a rounding error, but that should be okay. Actually, Danny, the same thing for you. There's probably a rounding error. You guys are off by just maybe about like a couple cents.
Mr. Kim,
Yes.
what's the formula again for the continuous interest?
A is equal to P e to the power of RT like this.
So when you're typing in E, you would just do natural log?
Second and then natural log.
Okay, and then for the rate, would you do 6.95 or 0.0695?
0.0695. It should be in decimal. Yep. Okay. Tony, Danny, Yethmi, and Audrey. You're all good to go.
Mr. Kim, did you get mine?
Yes, I'm moving down the list here because this is a big class. So just give me some time. Liz and Rachel, you're good to go. Nora, you're good to go.
Wait, Mr. Kim, am I good to go?
Yes, Danny. You were off by just a little bit, but I think that was a rounding issue. So, but you do have the amount that I actually wanted you to get, about the same.
All right, thank you.
Yep. Joshua Spence, I'm not sure, you were off by a digit.
Yeah, I
Like, or-
think I put in 1,000 instead of 100.
I gotcha. Yeah, so make sure that the p-value is 100.
Yeah.
And Ashley, I need the difference for DOB as well. Paulina and Jamie, you're good to go. Julia and Emma L. Good to go.
Mr. Kim.
Yes. Oh, actually, I'm looking at your second message. Yes. So Ashley, you're good to go here.
Thank you.
Did
Yep.
you get mine?
Abigail and Emma, you're good to go.
Mr. Kim, did you get my answer?
I am actually reading at yours right now. Perfect. Sophie, Andrew, and Amelia, you're all good to go.
Mr. Kim, do you see mine? I don't know where I went wrong.
Yes, Zach, that's correct. Well, the question you have for like B, the amount that you got for B is right. So you just
Yeah.
have to calculate the difference. Maybe the first one when you typed it is probably that was the issue why.
Is my A correct? The formula? So
Sorry,
I don't.
I'm just going through the rest of the students' one. Just give me a minute.
Yeah, that's fine. I just
Can you see my
I'm-
submission?
trying to
Yes.
find where I'm wrong.
All right, Sam, you're good to go, and Joshua, Ryan, you're also good to go. Yeah, so since I just have you two here, the second amount that you guys should be getting is 114.88. Well, 114.88 should be for bank A or
Yeah,
the
I got
deal.
one. I got 114.88 for bank A, and then 0.91
What you get
for
for bank B?
114.91.
114.91 is not so that means your bank B is not correct here. Make sure that you have principal as 100, e raised to the power of 0.0695 times 1 year. It's just for 1 year here.
Okay, so when I type that in, it's 100 times second
Natural log.
natural log, and then to the power of what is it? Rate time.
0.0695.
Okay.
Yep. And Joshua Spence, I got your message. Yes, that's more like it. About 7.69. That's the difference.
Oh yeah, it's like $7. I see. Well, wait here. Minus 107.197. It's like $7.69.
Yes.
Yeah,
So both of you guys got the same thing.
That's probably why I put 7691, just because that
$1,000.
answer is one it's 10 times greater because I kept plugging in 1,000 instead of 100, so that makes sense.
Yep. So I looked at your answer, so I knew that was probably the only issue why. And yeah, that's all you got to do. So great job, guys.
Thanks.
All right. Have a great weekend.